Welcome to the second part of my definitive laser system series. In this part, we're going to be taking our laser from the previous part and attaching it to a spawner and attaching it to a cube and testing the redirection, testing for infinite loops and such. We won't be adding any conditions yet. That will be in the following parts, or any color change. This is just the bare minimum for now, and then we'll move forward from that point. Let's get into it. So last time we left off with just a laser. We might need to reopen it later to make some changes, but for now we're going to focus on AC handler and SC emitter. So open SC emitter up, make sure you choose open full blueprint editor, and for the handler we'll have to do the same, open full blueprint editor. Now, I think we're going to start with the emitter, and even though some elements won't be complete until the AC handler is ready or may not be clear, I'm going to try and make it as clear as possible. So we're going to get rid of the event tick. We're not going to actually need that. The first thing we want to do is we want to go into our class settings and make sure we add our interface, because that's how all the logic is going to get called, as in starting, hit, and stop. So implement interface, we want to look for BPI lasers. This will create these two functions that we're going to use, or in our case, there'll be custom events. So the first thing we want to do is we want to get a reference to our owning handle. So we want to get a reference to this actor here, that will be, or this component, we want to get a reference to this component that'll be attached to the same actor as the emitter itself. So to do that, we're going to do get owner, and this is going to be on the begin play. And from the owner, we want to get component by class. And the component by class we'll be looking for, or the component we're looking for, is our AC handler. So underscore, and we have our handler here. So first we need to check if this is valid. So promote, sorry, not promote, that's the wrong thing. Drag it out and say is valid, and we'll take the second one and plug this in right here. Now if it is valid, then that means we can save it. So we're going to drag this here and promote it to a variable we'll call owning handler, and we can just plug this into is valid and just add a reroute here. So that's all we have to do for begin play. Now let's get into the event hit. So, or maybe that's not the correct term. Sorry, it's the laser start hitting that we want. So double click it and it will appear here, and we'll do the same thing for the stop, but we will start with the start. The first thing we want to add here is a branch, and we'll add this branch by pressing B and left click. And what this branch is for the invert system. So what is the purpose of the invert system? So the invert system, what it does, to explain it briefly, is a laser by default, how you think about it, or a cube, doesn't emit a laser until it is hit by another laser. Now, if we invert the system, it will always be active until it gets hit by another laser. If that is the case, when a laser hits this emitter or activates this emitter by hitting it, then we need to tell it to deactivate instead of activate. So that's why here we need to check if that is the case. Now, so to set up this condition, we need a reference to our handler. And our handler doesn't have that set up yet, so let's just go and quickly create that boolean for us. So variable plus, and we'll call this invert system. And we want to make sure this is instant editable by clicking on the right here, or by clicking on the I right here. So if we compile, just so it knows that it exists, now we can say grab our owning handler, control and click, or control and drag and place it in, and then we want to look for invert system. Now, because we're going to be using this a few times, we're just going to convert it to a macro, and we're going to do that with a lot of stuff here because there are a lot of macros that are reused. So right click on, after selecting both of these, not the branch, just this, right click, and we will say collapse to macro, and we'll call this does invert, or is system inverted. That's all it's going to do. So right here, we'll do that. Now, also one thing to note, we don't need to do a check here if this is valid before all this, because this function is called from within here. So that means it has to have this be true for this to happen indirectly. So what this means is on true, we're going to call deactivate or remove the laser. Whereas on false, we're going to call spawn laser, because the laser isn't inverted, so we need to create it. So we're just going to do a reroute here, reroute here. I'm going to select this one, collapse the function, and we'll say activate laser. And we'll select this one here, and we'll say function as well, deactivate laser. Now, let's go through them. So we're going to start with activate because deactivate is based on removing a laser that is already there. So we'll start with activate. So double click to open it up, and I'm just moving this to the top. Pretty simply, all we have to do, because we've already set up most of our system inside of our laser itself, we just want to say spawn actor from class, plug this here, select our actor, which is the A laser, and this will give us a lot of inputs that we need to create here as well. First of which is we'll do the color. We'll promote this to a variable, which we will call current color. And this variable, unlike the previous one, is not actually going to be exposed. We're going to handle it differently later. The owning handler is the owning handler. The previous lasers we don't have yet, so we're going to make a macro for that as well. For now, it's going to be empty, but this will do. So drag it out, press R to make a reroute node, right click on it, collapse to macro, and call it get filtered lasers. Now, for now, this is not going to do anything, but that's fine for what we need. So this is still an error here because we haven't done that. For range, we need to actually create a variable here for that. We are going to promote to variable, and we will call this max range. There we go. Plug this in right here. And we actually need one last thing that I forgot to do, and this we actually need to modify in the A laser. So just to find it, we can do browse here, open it up. Is we need another exposed variable, which is going to be similar to the previous laser, so just duplicate that one. And it's going to be called actors to ignore. And so what this will be for is that we can ignore them in here. So this needs to be converted to a basic actor class, so just search for actor. And because it's already an array, don't need to change that. So grab the actor, or this actor to ignore, and plug it into actors to ignore. And then the last thing is we need to make sure this is instance editable and exposed on spawn, but because we copied our previous laser, that's already done. So we can compile this and close it. Now, if your actors to ignore isn't appearing, there's two things you need to do. One, make sure you compiled, because if you don't compile it won't know it exists. And if it's still not appearing, right click here and say refresh nodes, and then it should appear. So now for this one, we want to make an array, and in the array, we're going to say get owner. And here, make sure you don't get this one. So this is the wrong one. I shouldn't have done it this way, but when we say get owner, we need to make sure we choose the component because we're currently in a component class and not an actor. So we need to make sure we choose this one here. You can tell the difference by the target right there. So if we compile, we still get an error because we don't have our transform, but for the transform, we just want to say get world transform right here, and that should do it. Let's finish this off very quickly, and then we'll just make a quick debug so we can test this to see if the laser is spawning correctly. This will be promoted to a variable as well by dragging, say, promote to variable, and we'll call this attached laser. And because of how this works, because it is the emitter, and it's going to be controlling the laser that spawns, it doesn't matter whether this laser will be spawned on either a cube or on the spawn or a reflect. It doesn't matter. We want to attach it to the parent actor. So we wanted to attach it to a component. So we're going to drag from our attached here and say attach actor to component. And that way we can attach it to this specific emitter. So if we move the emitter, we can also move the laser itself. So here we're going to say for the parent is just self. And we want to make sure, and if you don't do this, you'll have a lot of issues. We want to remove keep relative and put keep world in all three categories. We don't need to weld simulated bodies. It doesn't really do anything here because we're not actually simulating physics on the laser itself. So it doesn't matter. There we go. So with this, we now have an activate laser. So to check if this is going to work, we're just going to put it on our begin play here. So it's not actually going to be here later, but just to test if we can spawn a laser correctly, we're going to do that. And because it's a component, we can't actually drag this into the scene and do anything with it. So what we'll do is we'll make our first cube here, even though it's not going to work yet. We're going to right click, create a blueprint class, create an actor, and we'll call this a cube. And this cube is going to be the redirector. I'm not exactly sure the best term for this, but it's going to, if it gets hit by a laser, it will spawn a laser from the predetermined emitter that we'll place in it. So To that, we will add first a static mesh, and we'll put this right here, replace the default scene, we don't need it. And the static mesh is going to be a chamfer cube. There we go. And so the last thing we need for this to work is our actual component. So we're going to look for SC emitter right here. Now by default, it's not in the right spot. So we're going to move this forwards. There we go. And that will do it. Now one thing actually we can do, because we're not actually going to need to see this here, so we can actually make it private. So let's just do that very quickly. So select our owning handler, set it to private, compile, and now we only see the two variables that we actually want to change. So that's these two. So with this, we now should have a laser that spawns, and it's going to be the color here. So let's just change this to be red. There we go. And normally, if we place this cube in the level, we should have a laser that spawns, and that ignores the actual cube itself. So it should keep going, even though the emitter, if we look here, is actually on the edge. So let's try it. And it does work. So it was just getting blocked by the player there, but it is working as expected. And if we push the cube, oh well, we can't push the cube because I haven't told it to simulate physics. So let's just quickly go and do that. So in the search bar, just simulate physics, and there we go. So if we now try and push it, it should actually move the laser with it as well. There we go. So it's working exactly as intended, but right now it doesn't have any interaction whatsoever. We're just going to set that up next. We can close our E cube for now. We actually only need to add our handler to it, so maybe we can just do that now, even though it doesn't have any information. So there we go, place a handler, and the only thing that we can check now is the invert system, but it's a cube, we want it to actually get hit, so we're not going to invert the system here. So compile, and we can close our cube. Now, the next thing we need to do is the other function we made. So we're going to remove the activate laser here, and now we're going to work on deactivate laser. So deactivate laser is extremely complicated. We want to get an attached laser here. We want to check if it's valid, and then we want to tell it to stop hitting actor. So the one we're looking for is this one right here. Sorry, not that one, sorry. We want to say stop hitting laser. So this one right here, and it will appear like that. And for the input, we don't need anything because we're telling our laser to stop hitting, which if you remember in our A laser right here, this, what we're referring to here is this function right here. We're telling it to let anything it's hitting know that it no longer exists, and then we destroy it. That's all that we have to do here. That will destroy our laser for us and handle everything it needs to. Because most of the logic is inside the laser itself, and it will handle it from there. So that does it for our activate and our deactivate laser. So just like with our start, we now need to do the same thing before the stop. So let's just copy these down, and we can't obviously just copy them like this. We need to actually tell them to be inverted. So, or the opposite of what is up here, because now if it's inverted and it stops hitting, we want it to activate. Whereas if it is inverted or is not inverted, we want it to deactivate, sorry. So just to be clear, if the system is inverted on start hitting, we deactivate. If it's normal, then it activates when it gets hit. Whereas if it's inverted and we stop, we want to activate it. Whereas if it's normal, we want to deactivate it because it's not being hit anymore. So compile and save. And that will do it for now, at least for our basic cube, for our emitter, sorry. So the next thing we need to work on is our handler here. So let's get into it, because this is where the bulk of the work is going to be. So the first thing we want to do here is we want to make sure that we know which components are attached to this handler, which ones are a part of this same actor that need to be told to start emitting, for instance. So we're going to put a sequence here just to keep things a bit more organized. And the first thing we are going to do is get those components. So we're going to get our owner. That way we have the actor that is in charge, so to speak, of this handler. And then we're going to say get components by interface. That way we're not just limited to our SC emitter or to our reflect laser or to our external actor as well. We can just say, well, they're using that interface, so we'll just get them that way. So BPI lasers. Now we also need to, before I forget, add the BPI to this actor, this component as well. So right here, BPI lasers as well. So once again, in class settings, in the details, we want to select our implemented interfaces. So it should appear like this. So with this, we're going to then say promote to variable. We'll call them linked components. And we can keep this as private so it doesn't appear anywhere, but it doesn't really matter too much. Just to give you an idea, if this isn't private, for instance, and we leave it like this, if we look at our block again, our cube, then if we look at our AC handler, we actually see our linked components and our invert system, but we don't need to see our linked components. That's all handled locally, so we can actually hide that. So right here, select this, make sure it's private. Now, the one thing we do need to do with this, and it's very important that you do this, otherwise you will get some infinite loops, is we need to make sure that we are not, in our linked components, talking to the handler itself, because otherwise once we start saying, oh, well, all the linked components need to be activated, it will be activating itself, and that will cause an infinite loop. So we want to make sure we say remove item, and we'll look for self. So line that up, there we go. One thing we do here that is very, very simple to the system, and is also a condition here that we can add, is do we want the object that this handler is on to be solid, to block the laser? So if we want it to be that, we're going to call this variable isBlocking. And we'll make it appear above here. We'll make this be a category for conditions, because that's what they're going to be for. So isBlocking and invert system. Make sure isBlocking is instance editable as well. And here we're going to add a little branch, which is just going to say, hey, if it is blocking, then we want to make sure that we change the collisions. So by default, actually, sorry, no, there's a better way to do this. So we're not going to do it that way. What we'll do is we will say, once again, our get owner here, and we're going to search for, once again, classes, and this is get components by class this time. And we're just going to use the static mesh component class. And then we're going to add a for each loop right here, plug these both in. And for what we're going to do with the blocking is we're simply going to say here from our array element, set collision response to channel, and the channel we're looking for is the laser, the custom channel we made. So select laser, and so here what we want to do is we will use a select. The index / wildcard will be the is blocking. So if it is blocking, it's going to be block, otherwise it's going to be overlap. Now it's important to use overlap and not ignore, because if it still passes through and it has conditions like one of the objects with one of the components within here, we still want it to do something. So we want to make sure it's overlap and not ignore. Just move this a bit closer. Now we can do our invert system. So right here, grab our invert system, put a branch, and what we'll say is if invert system is true, then we want to start. We want the object to work. So what we're going to do is we will say, once again, now in this case, sorry, we're not going to use our linked components here, because in the event where we would have a wall that is bouncing a component, which we're going to make later, we don't need to pre-activate that, because you can't pre-activate it without knowing that a laser is hitting. You can't really have an inverted system for a wall that bounces lasers, because no lasers would hit for it to bounce, so that doesn't work. So making that assumption, I kind of just built this by saying we will get components by class, and not components singular, we want to get components by class with an S, and we're just going to do the SC emitter here, because it's the only one that can be activated without any pre-existing conditions. So we add a for each loop on true, and right here we'll just go through that loop and actually just simply activate them. So right here we will say actor, and make sure we're not actually saying to activate. We're not calling it activate here, this one that we made, but we want to make sure that we use our start hitting instead, because right now, although there aren't many conditions, there will be later more to check if it can actually work. So the top one, and as far as information goes, well, there isn't anything, because we don't have that. Now, sorry, no, I made a mistake. We don't want to do start, we want to do stop hitting. And the reason we want to do stop is because the system is inverted, meaning that it will go here, it will say it is inverted true, and it will say activate. Whereas if we do it here, it would say inverted is true, so we deactivate. But that's not the case. We're technically telling it to say that it's not being hit anymore, so it can be activated because it's inverted. It's a bit complicated sometimes when you think about it, but if you follow through the flow of execution, it makes sense. Before we move forward, let's actually showcase that this does work by making another actor here. So we're going to duplicate this, and this will be our A spawn. Now, if we currently do run this, nothing should happen. This laser doesn't shoot, and the reason for that is because the system isn't inverted, so it will work once it gets hit by a laser. Now, we could, I believe, push this in here once we have our system working, but it wouldn't work too well because this laser doesn't actually technically exist in the system, so to speak. So we're going to delete this one here for now, and we're going to replace it with our spawn here. So I'm going to change the static mesh here so it's more visible, and what we'll replace it with is we will get a cone, and we'll just use that instead. Now, this time our emitter needs to actually be moved because it's in 0, 0 for now, and I think we'll need to rotate it as well, but I will just drag this up for now. So you can put it on 50. I think a bit lower is better because otherwise it looks a bit weird having it be exactly there. So range 3000 still, we don't change that. We want to make sure in our AC handler this time we do click Invert System here. And so we can compile. And now if we place this in, I think the laser will be in the wrong direction because I can never remember which way to point it. But if we do play, we have a laser. Now, as you can see, it's not supposed to go out this way. So we'll fix that in a second, but the laser is indeed spawning. Even though it's not being hit, it knows that the system is inverted so it can exist without it. Okay, so let's just fix that rotation very quickly. So now if we just, I believe, rotate it upwards by 90 degrees, so put 90 on the X, that should solve the issue. Let's try again. And that did not solve the issue. There we go. So it was the pitch. So just make sure that your pitch is set to 90. I don't see why these need to be 360. I think it does it automatically. So 90 on the Y, and then you should have a laser that points straight up based on the cone itself. So obviously if you don't want to use a cone, that's fine. It's up to you. Not a problem at all. So let's just move this to the edge because it's never actually going to move. And there we go. But yeah. Oh, so what happened there? Oh, sorry. There's a little bit of an issue. We left the physics enable. So let's just disable that because it's a spawn. We don't want it to move. There we go. Perfect. Okay. So the next step now is to make it that if we hit the cube, this tells it to activate. So to do that, we need to add some extra little bits here that say start hitting and stop hitting. So let's do that first. Now right here, if we just do start and stop, we can actually check if these work with a basic print because we've already set up the systems that if a laser hits something, it'll let it know in this actor here. So back in our handler here, if it starts hitting, it will say hello. If it stops hitting, it will say goodbye. So let's try this. So now it's not saying anything because nothing is being hit. If it hits the player, it doesn't say anything because the player doesn't have the actual AC handler to work with. Now this cube does though. So if we hit it, it says hello. If we push it out, it says goodbye because it knows that it's not being hit anymore. So that means at least this is working as intended. It's only calling this once and it's only calling this once as well. So that's exactly what we want because we don't want it to be calling it all the time. That would be unnecessary calculations for absolutely nothing. So this is good. So let's move on with this. So what we want to do here for both of these is we want to have a means of storing the lasers that are currently hitting. Now, although now we don't need to know that, later on we will. So we'll just take the time to very quickly add our very quick function here. So I'm going to promote this to a variable, and this will be called lasers in queue. We're calling this in queue because we want to make sure that if later down the line we'll have a system that kind of filters which lasers are authorized. So even if it's hitting, it'll only be marked as in queue, whereas we'll have another array that will say, okay, these ones are working. So we're going to right click this to turn it into a array, and we're going to drag this here, say add, and sorry, no, add unique, because I'm going to make sure it only calls once, even though it shouldn't call multiple times. It's just an added security. The input will go into here, and we're going to right click this and turn it into a function. So collapse to function, and we'll call this add or laser added. And just plug this here, leave it here. We're going to use it here, I think, and I think this is the only place we'll use it, but it's a bit easier to handle in a function than it is anywhere else. So we're going to duplicate it, and we'll call this laser removed. And inside of it, we will say remove instead of added. So remove item and plug in the new item to it. Let's move this to the top. There we go. And we can compile. So now if we add our removed here, we have a system that adds and removes our lasers. What we're going to do here is we are going to make our first macro. And with that macro, we are going to loop through this information. So we're going to say for each loop here, we are going to drag our execute, put a reroute. We're going to drag our body, put a reroute, our element, reroute, and the same for index and the same for completed. Now we're going to select this. So just the middle part, not the reroutes. Right click, collapse to macro, and we'll call this loop, for each component. And that's because we're going to use it a few times, so just have it be tidy is much, much better. So we're going to open it up because it makes a mess almost every time. And we'll just make the completed be at the bottom. That way it just lines up nicely. So we can close this for now. And all we have to do here for this to pretty much work is we say, well, start hitting. And this time it's a message because it doesn't know that this specific actor handles this. Whereas when we were talking to the emitter directly, we knew that it had this function. Whereas here it has to be a message because it will only be called if it implements the interface. And this time we do need the conditions, and the conditions are, well, this right here and the hit info, which is right here as well. So we'll just plug both of these in this, and we will plug finally on the bottom one as well. We will copy this and we'll put it at the bottom, and the same thing happens, except this time instead of start, we're going to say stop hitting, and connect both of these up, add a reroute here to know which is the input. There we go, and plug it in like this. So now if we go and push our cube in front, we should get a laser spawn once it hits, and it stops once it's over. So let's just try that again. If we keep it on, and as I mentioned previously, we added the is blocking, but if we go ahead and press F8 and look at this cube here, if we look at our handler, we haven't told it to block, which is why the laser is still passing through, but it's overlapping, so it still considers it a target because we set this up to handle multi-hits. So we can close that, and that should do it. So let's just actually make a quick change to our cube to make it block, because I think it's easier that way to handle. And let's check what happens if we make a loop. So right here, we're going to make this go and shoot to the left, and we'll make another one shoot in the opposite direction. And normally, if we've set everything up correctly, we shouldn't have an infinite loop. Let's play. Oh, there does seem to be an issue. So I'm losing a lot of frames here, and you can probably tell in the video. Something is going wrong. Okay, I figured out what the issue is. The reason is because the currently get filtered lasers is empty. So what that means is it considers this to be empty. So it's going and saying, well, we can, sorry, went a bit faster. So the issue lies in our activate laser here, where we are telling it to activate a laser and check where, and the whole system is working. The only issue is currently the lasers that it's supposed to filter out. So the get previous lasers, which if we check our A laser here, get checked right here on our handler is if it's not on the path. But the thing is, it is empty. We are never actually setting any values because by default we made it empty earlier. So that means it's always saying that the handler is okay, we can keep going with it, it's not a problem. So to avoid that for now, what we'll do is we'll simply go into our get filtered lasers, and instead of having it be empty, we're going to get our owning handler and we're going to say get in queue lasers. And for now this will do, we will change it later. But for now, this should do the trick to avoid our infinite loop. Let's play again. And there we go. We have two lasers and it is not looping. I have 74 actors at the start, 74 actors at the end. And if we block this, we have 0 because it deactivates the whole thing. And the same thing here, no problem. And again, once again, we see 72 because the two lasers are gone. And if we do it again, the two lasers appear. Now, one of the tests we need to do, and this is not immediately evident, you might not think of it, is what happens if we hit our laser spawner, because our laser spawner is designed to stop if it gets hit normally. So right here, it isn't doing anything because the laser already exists, but the thing is, it can cause issues potentially, especially in this case, it's not going to do anything because this is the same loop. So it's saying it's not on the path, so we don't handle it. But if we go here and create a second spawn, so I'm doing holding Alt and moving here, this one won't work because we are hitting it, and hitting a spawn or an inverted actor means, well, you don't activate. If we block it here, it'll reactivate. And so we need to fix that because our spawn here, we don't want it to deactivate. We want it to spawn at all times. Otherwise the whole puzzle might not work. So to do that, we're going to add a basic condition, which is called IsLocked. And if an actor is locked, that means it cannot change state, no matter what, except one condition we're going to put is if we have an external actor, for instance, a button to activate a spawn, then that will work. That will be allowed to interact with it. Otherwise, we're not allowed to touch it. So in our AC handler, let's go and make that. So is blocking, we'll duplicate it, and we'll say is locked. And if it is locked, we don't want to do any of this pretty much. So we're just going to move it all a bit. Sorry, no. We do want to do some of it. We don't want to do any of this, but we want to cancel, not allow this if it's locked. But we still want to let it know that the laser started hitting it. And the reason for that is if later down the line we say, oh, well, it is locked. But in addition, it does have some conditions that when you press the button, for instance, to activate the spawn, it also needs to have, for instance, another laser hitting it to work. If you want to do that, then we can still check for this and override here with our activate from outside. That's how we're going to do it. So move this a bit to give us a bit of space. And right here, we add a branch and we want to look for is not locked. And we'll just put this here, And I think we will turn this into a macro. So I'm just going to select, add a reroute here. I'm going to select both of these, right click and say collapse to macro. And we will say is locked, is not locked. And so right here, if we select on the left here, we can just change the names. So this is going to be true. So this is going to be not locked. And this one is going to be for locked. So we can just remove that. Move our macro a bit to the side. And we'll just copy it here at the bottom. And we will do the same thing because it has nothing to do with if it's hitting or not. This is just a matter of whether it can change. So right here, if it's not locked, we can do all the rest in both cases. So right now, even though this is going to get hit by our laser here it still won't change anything because we haven't told it. So if we go into our spawn here by selecting it in the bottom right here, open blueprint editor. For our AC handler, we want to make sure we say it is locked. So compile. And now if we play, that laser will still spawn, even though it is getting hit by this one and this one. It doesn't matter because its conditions are telling it not to take into account any kind of hits as far as it goes for activating or deactivating its components. Thank you for watching. I hope you enjoyed this, and now you have a fully functioning basic laser system. I think in the next part, what we'll be doing is we will be adding the laser to reflect on the wall, because currently right now we have our laser redirector, we have our laser spawn. Let's add our laser reflect in the next part. Once again, the Patreon files are not available yet. If you are interested in those, it will be on after the last part goes live. I want to thank everybody who supported me last month and is currently supporting me now. It means a lot. Thank you for watching, and I'll see you in the next part. Goodbye.